Welcome to this explainer. Today we're diving into the really fascinating mechanics of converting PDFs to web-ready SVGs, but with a major focus on absolute data security. You know, if you frequently work with vector graphics, technical documentation, or maybe web design, you already know how absolutely crucial it is to extract your assets cleanly. So we're going to look exactly at how modern browser-based tools make this happen securely. Let's just jump right in. So I want you to think about the very last time you uploaded a document to one of those free online converters. Did you ever pause to wonder, where does your PDF actually go when you hit that convert button? I mean, if it's just a takeout menu for a local restaurant, yeah, maybe it doesn't matter. But what if it contains unreleased product designs or highly confidential financial charts, maybe proprietary engineering schematics? When you use a traditional cloud-based converter, your data literally leaves your device and just sits on a server you have absolutely zero control over. Today, we're examining a completely different, highly secure approach that keeps your data exactly where it belongs. With you.
All right, Section 1, the user experience. The whole workflow breaks down into 4 incredibly simple steps. First up, you just upload your PDF file. Second, you visually select the pages you want. You actually get these great little thumbnail previews of every single page, so you don't have to waste time processing a massive document if you literally just need one specific chart. Third, you adjust your quality settings, which we'll dig into a bit later. And finally, convert and download. What makes this workflow so incredibly efficient is that if you're batch converting multiple pages, the tool just bundles the whole shebang into a single, clean zip archive. One click, and you're done.
To really wrap our heads around why this specific tool is such a game changer, I absolutely love this analogy. Think of traditional cloud converters like sending your family's closely guarded secret recipe to a bustling restaurant kitchen to be cooked. You have no earthly idea who's back there reading it. But this browser-based tool, it's like bringing those high-end commercial appliances right into your own home kitchen. All the processing power is downloaded directly into your browser, which means your document, your secret recipe, never actually leaves your device, not even for a second.
Moving right along to Section 2, under the hood mechanics.
So what's actually happening when you drop your PDF into the tool? The data flow is honestly brilliant. Phase 1 kicks off by using Mozilla's open source library pdf.js to read the file's internal structure right there in your browser's memory. In Phase 2, pdf.js interprets the vector graphics and text and then renders them onto an invisible HTML5 canvas element. Next, in Phase 3, that canvas is exported as a super high-quality PNG data URL. And finally, Phase 4 wraps that rendered image perfectly inside an SVG container. It's basically a brilliant little automated assembly line running entirely in the background of your browser. Now, I want to be strategically transparent here for a second about a really vital technical detail: rasterization. The vector PDF content is actually being rendered into a high-resolution pixel grid within that canvas buffer, meaning the tool isn't performing some complex true vector-to-vector extraction of every single mathematical path. True path extraction usually requires heavy, expensive desktop software like Adobe Illustrator. Instead, this tool is capturing an exceptionally high-resolution snapshot.
So you might be wondering, well, if it's rasterizing the image, why wrap it in an SVG at all? Great question. It's because SVG is the native vector format of the web. By wrapping our high-resolution render in an SVG container, we get a file that behaves beautifully in modern web design. It's completely scalable within the bounds of that high-res render. It often yields way smaller file sizes than those bulky JPEGs. Plus, it allows for seamless CSS styling integration, and it boasts universal support across literally every modern web browser out there.
Okay, let's talk trade-offs in Section 3, balancing resolution and size. There is a really vital trade-off you need to manage here. A 1x scale renders at native resolution. It's fast, it's small, but it might look a little soft on today's super crisp screens. Then you have the 2x scale, which doubles the resolution. But you've got to watch out for the jump in file size here. Because you are doubling the width and the height, a 2x scale actually quadruples the total pixel count. That leads to files that are roughly 4 times larger. 4x scale pushes this even further for maximum quality, but man, it yields massive files. This is exactly why 2x is widely considered the absolute sweet spot. It perfectly balances crisp visual quality with solid web performance.
Let's put this into perspective so you know exactly what to choose. If you are just making quick thumbnails or rough previews, stick to the 1x scale. Are you extracting charts for a blog post or maybe some web icons? Definitely use the 2x scale for that perfect retina display sharpness. Now, if you are pulling a logo for a massive high-res presentation display, you probably want to bump it up to 3x. And if you are dealing with really complex technical drawings, CAD exports, or intricate architectural diagrams that people are going to zoom way in on, that 4x scale is going to be your best friend. Which brings us to the most important part. Section 4, Zero Network Transfer Security.
Zero. I want to repeat that. Zero. That is exactly how many bytes of your confidential PDF are ever uploaded to a server or any third-party analytics service when you use this tool. Literally zero. This is absolutely crucial for protecting your proprietary data. Because of that PDF.js and Canvas architecture we looked at earlier, all the heavy lifting happens locally. There is absolutely no server storage happening. The entire conversion process occurs entirely within your active browser memory. It utilizes complete session isolation. And what does that mean for you in plain English? It means the exact moment you close your browser tab, the slate is wiped entirely clean. Poof. Gone. It is as if the file was never even there, making this literally the perfect method for handling highly sensitive, unreleased designs. The contrast here is just night and day. With traditional cloud converters, you're constantly risking data exposure during the upload process itself, and you often find yourself stuck waiting in these artificial server queues if the site happens to be busy. But contrast that with this modern browser-based tool. You've got zero network transfer, which means zero risk of interception. Plus, you get instant local processing powered by your very own device's CPU. No waiting in line, and absolutely no compromising on data integrity. It really all boils down to this one simple truth: complete privacy. Your PDF is never uploaded anywhere. By bridging the gap between the universal PDF standard and the modern web's SVG format, and doing it entirely within the client side, you are getting the absolute best of both worlds. You get stunning, high-quality web graphics and total, uncompromised peace of mind. So, we've covered the mechanical assembly line, the optimal scaling strategies for web performance, and the incredibly robust security features that make this tool tick. Now, armed with the knowledge of exactly how your data remains totally isolated in your own browser's memory, I want to leave you with this thought. What confidential document will you safely convert to a web graphic next? Thanks so much for joining me for this explainer. Have fun and happy converting.